exponents. First thing I want to do, on your notes, go ahead and write x to the 8th power. Go ahead and do that for me on your notes. So you have the title, Rules of Exponents, go ahead and write x to the 8th power. Go ahead and put a box around that puppy, all of it. Put an arrow on the x. So if something is raised to a power, the something is called the base. Go ahead and write base. The little number up here starts with an E. Can anybody remember what that is? Exponent. Go ahead and write exponent. We got the base, we got an exponent. Sometimes the base is a number, not a variable. Now together though, the base with the exponent, thank you, appreciate that. The base with the exponent is called, now put an arrow on the whole box, the whole shemak. It's called a power. Let's get some vocab out of the way. We got to be speaking the same language or we ain't going anywhere. Exponent, base, the whole thing with the base with the exponent is called a power. Cool. We're ready to rock and roll. Go ahead, Dusko. So what I'm going to do right now, I'm going to throw 6 rules of exponents. In other words, if you have math problems that have all these exponents all over the place, what are the rules that will guide us in handling problems with exponents? That's what I'm going to throw at you right now. Very straightforward. There's 6 of them. I think there's 6 if my coffee kicked in. Here's the first one. Go to write number 1 on your notes and go to write 0 exponent. What if you come across an exponent that's 0? Go to write this down. So the words mean the rule. The rule is in words. The numbers, this is an example with numbers. The algebra, this is an example with variables. So look at in words what the rule says. For any non-zero number. How many non-zero numbers are there in the universe? How many numbers are non-zero? A lot. So how many would that be? Infinite, right? So look at, for any non-zero number, there's an infinite amount of them, right? There's an infinite amount of non-zero numbers. There's only one non-zero number, which is 0. But any non-zero number, a, let's pretend it's just a variable a, and that number to the 0 power is always going to be a 1. It's kind of weird and funky. So this is the first rule. If you come across a 0 exponent, it's going to be 1. The answer will be 1. That's all this is saying. Nothing more, nothing less. So we're going to put a number 1. It's called 0 exponent rule. Write that down. Rule number 2. Negative exponents. What? First we got an exponent that's 0, now we got an exponent that's negative. How the heck do we handle that? Write that down. So right now, phone's away because I have the floor. You lose a stamp, right? I'll give you time to look at your phones later. This is what the video went over. What does the rule say? Okay, for any integer. Now integers mean, if you forgot what an integer means, I'm going to put just negative and positive whole numbers in parentheses. A skinnier marker. So for those of you who forgot what an integer is, you've heard it before, I know you have, don't even lie to me. This word integer means, in parentheses, negative and positive whole numbers. That means not fractions. Whole numbers. So this rule is saying, look, you have an integer, n, and any non-zero number a, a to the negative n power is the reciprocal of a to the positive n power. What the heck does that mean? I'll explain. Just write it down. So 4 to the negative 2 power becomes 1 over 4 to the positive 2 power. That's an example of numbers. A to the negative n becomes 1 over a to the positive n. Something funky going on with this reciprocal word. You've seen that in junior high. We'll go over it right now. Give yourself some space. I want to cover one example. Another example here. So here's two examples.
What's that middle thing in front of the...
Negative, which one, right?
Like by the negatives, and the negative and positive?
Negative and positive whole numbers.
Oh.
That's the hashtag symbol, number symbol. You guys are millennials, huh? You guys know that the hashtag really means the word number? I trust. Numbers. Like this. Okay. Don't hold there. My generation, that just meant number. The hashtag symbol means numbers. What is that? Yeah, it had nothing to do with the word dumb. Just more of, maybe they didn't know. A lot of stuff you don't know. You know, relax. So, what do I mean by reciprocal? Check this out. So underneath the second rule, give yourself a little bit more space. I want to go over one more example because a lot of students get hung up. I'll put it back up. Don't stress. So underneath that, here's one example, another one here. What if I have, Burns, what's your favorite number?
3.
3 to the negative 8th power. Go to write 3 to the negative 8th power. Go to put EX for example. Again, you're on rule number 2. Give yourself some space. Go to write example, EX for example. 3 to the negative 8th power. I think in junior high, I'm pretty confident, or even before that, middle school, your middle school math teacher taught you how to take a reciprocal of a number. Reciprocating means you flip the numerator and denominator. Looking at 3 to the negative 8th, Burns' favorite number 3 to the negative 8th power, how would I make this into a fraction just as it stands? How do I make anything into a fraction? Right, so look at it. Just go like that, right? That's middle school. Any number is over 1. So this rule is saying, look, if you have a number to the negative power, all you got to do is reciprocate, take the reciprocal of the fraction, but make the exponent positive after. So this is really 1 over 3 to the positive 8. Done. That's it. That's all this rule is saying. You have a negative exponent, you flip it and make the exponent positive, you're done. Let me go back to that second rule for those of you who didn't finish writing it down. So here, the example they gave you, look at 4 to the negative 2 power. They didn't tell you what I told you, just make it a fraction first, then you flip it and make it a positive exponent. Okay, so that's all they did. How about a to the negative n power? Put it over 1, flip it, make n to the positive. So far so good, no harm, no foul. We're rocking and rolling. Third rule. Product of powers property. Let A be a real number. No, just get no paper up. We're on the third rule. Let A be a real number and let M and N be integers. To multiply powers with the same base, add their exponents. Look at the numbers example, and then the algebra example. Hey, they're using that word I went over. Remember in the beginning? Power. Power means a base with an exponent. If you have a power multiplied by a power and they have the same base, all you got to do is add the exponents. Are you kidding me? Can it be this easy, this math class? I can't. I'm starting to feel guilty. This is so easy.
Should make this pass harder or something.
What's going on here? Look at the example here. 4 to the 6th times 4 to the 3rd. What is the basis here of these two numbers? What's the basis? 4 to the 6th times 4 to the 3rd. What would be the basis here? 4. Look at the same base. If you're multiplying with the same base, all this rule says, ladies and gentlemen, add the dang exponents. 6 plus 3, so it's 4 to the 9th. It's all the same. Look at here. Look at the bases here. Same base. A and A are the bases. All you got to do is add the exponents. So it's a to the m plus n power.
So they don't have the same base and you don't add them.
Beautiful summary. Say it one more time.
So you don't have the same base, you don't add.
Exactly. This only works if they have the same base. Perfectly said. See, powers with the same base. This does not work if they don't have the same base. Moving right along. We're rocking and rolling. Okay, this is multiplying. Product means multiplying. What if you're going to divide now? What if you're dividing now with the same base? This is the 4th rule. It's very related to the 3rd rule. The only difference is that we're dividing instead of multiplying. But everything's the same. With a slight adjustment. Same base, 4 and 4. Look at that's just like over here, 4 and 4. But what do you do with the exponents? You subtract those puppies. Subtract the exponent. 6 minus 3 is 4 to the 3rd. You're dividing with the same base. Look at A and A are the same base. It's going to be m minus n power now. So the moral of the story, if you're multiplying with the same base, add the exponents. You're dividing with the same base, subtract the exponents. I'll leave this up here for another minute or two. Copy it down. Sure. Again, this example right here is with numbers. This example is with algebra, in other words, variables and such. So every rule I give you, there's 2 examples, one with numbers, one with variables. Okay, let's keep going. Last 2. Almost done. You guys are doing excellent. 5. Power of a power. Someone call me? No. Next question? Watch the language, thanks. Let A be a real number, let M and N be integers. You know what? For the rest of it, don't even worry about writing this down. This is garbage. Skip. Don't worry about writing this part down. What if you have a power raised to a higher power? That's what's going on. Look at power raised to another power. What the heck you do? Well, you just multiply the exponents. You got to be kidding me. This is that straightforward. We find a power of a power, multiply the exponents. It's straightforward. Boom. Right, Ramirez? I need to agree. Rocking and rolling. Last one, I think. 2 more, my bad. Forgive me. My coffee didn't kick in yet. Power of a product. Again, don't write this part down. This is unnecessary for now. Second to last one. 6. So power of a product property means to find the power of a product, find the power of each factor and multiply. In other words, if you have stuff being multiplied in parentheses, all raised to a power, just take each factor. Look at the 3 to the fifth power and the 2 to the fifth power, and you're rocking and rolling. That's it. Power of a product. Product means multiplying. If you're multiplying a bunch of crap inside parentheses, take each piece of crap to the outside power. Kind of like what it's saying. Last but definitely not least, last rule of exponents for summer school. Rule 7. Power of a quotient. Again, ignore this part. So you have stuff being divided in parentheses. You could take every item to that power outside, to the exponent outside. That's all it's the same. By the way, this clock is exactly 1 hour behind, so whatever you see, just add an hour to it. Right? So it's 11:40 right now. Just so you know. But that, I don't have a screwdriver to fix it. Anybody have a screwdriver, let me know. Seven rules in all their glory.